Isotopes. At the board, you are seeing the atomic symbol. I'm using the atomic symbol. This place is the atomic number. The one at the top here is the mass number. I said this is what? The atomic number. And this is the mass number. And this is carbon. And under this carbon, this is the atomic symbol. This is the atomic symbol. Now, under isotopes, I will introduce this topic. The subsequent topic will be calculation involving isotopes. Now, the number of protons present in an atom is the same thing under isotopes to be the atomic number. Notice the number of protons. The number of protons is equivalent to the atomic number. The atomic number. Now, there is a simple formula you should also know, that the atomic number is also equals to the number of proton plus the number of neutron. Now, under isotopes, the atom has the same number of protons but different number of neutrons. I said again, under isotopes, the atom they have the same number of protons but different number of neutrons. Now, remember, if from here, if the atomic mass is equal to the number of protons plus the number of neutrons, that means if I ask you to calculate for you to get the number of neutrons, all you have to do is you cross this will cross the equality sign and the sign will change. So this will be atomic number minus number of proton. Stay with me, please. So if I want you to calculate the number of neutron in this atomic symbol, is just 12 minus 6, and the number of neutron will be 6. Remember, I said in isotopes, the number of neutrons are different, but they have the same proton number. And I went ahead and said that the number of proton is equivalent to the atomic number. I just said it. Now, what about if you have this compound here? You have chlorine. If you have chlorine and chlorine, this is 35, 17, 37, 17. If you have that compound above, you can see from here, this is a very typical example of isotopes. Look at the atomic number. The atomic number is the same. You can see that they have different mass numbers. The mass number or the atomic weight, you can see they are not the same. And this is a typical example of an element exhibiting an isotope. Now, from the above, you can know that the atomic number, from here you can know that the atomic number is 17. They can also ask you, what is the proton? The proton number here is also 17. Now, if I ask you to get the number of neutron, the neutron number is equals to what? 35 minus 17. Now, for this other one, the neutron number is equals to 37 minus 17. Now, here you will get 18. This is 18. So the number of neutron here is 18, while the number of neutron here is 20 neutron. Now you can see, like I said, they have the same atomic number, but different neutron number. At the part 2 of the video, I'll be talking about the isobars, but I will introduce it in this video. Remember, this is introduction. Stay with me. Now, in isobars, the atom of two different elements can have the same atomic mass. The atoms of two different elements can have the same atomic mass or weight. Please know this. Isobars comes from the Greek word iso. Iso meaning same. And the bars also come from a Greek word. It comes from a Greek word baros. Baros. And what it means is weight. So by isobars, it means same weight. They may be atoms from different elements, but they have the same atomic weight or mass. You can see here is sulfur. Sulfur is number 16, but it has an atomic weight of 60. Potassium number 19, it has an atomic weight of 40. Calcium is number 20, the atomic weight is also 40. Chlorine is number 17, the atomic number is 17, but the atomic weight is what? 40. Now, when you see something like this, you know that this is what? Isobars. And of course, you can know that they do not have the same number of neutrons, and they do not even have the same number of protons. Look at it. If you calculate it, here we have 16 the proton, and 40 minus 16 will give you 24 neutrons. And the same thing is here, 40 minus 19 will give you 21. So this is just a typical example of isobars. In the next video, I will focus basically on calculation. Please, I want you to know this thing. When I say nucleon, if I say you should calculate the nucleon number is also the same thing as the atomic mass. The nucleon number is equivalent, also the same thing as atomic mass. So on the part 2 of the video, I will focus basically on calculation on isotopes.